All right, welcome in. Unit percent, student handout 6. So there's 7 student handouts. This is the second to last one. This is percent era. Today, we're going to name that tune. So these are Disney's tunes. So name that tune. First one.
It means no worries for the rest of your days.
All right. Absolute error measures the difference between the approximate value and the exact value. So it basically tells us the difference in our guess and what it actually is. It can be solved by finding the absolute value, which is very important, the absolute value of the difference between the approximate value and the exact value. And the way that's going to look is a line for absolute value, a minus x, absolute value. All right, not very difficult, so let's go down here and solve it. A science experiment calls for 150 milliliters of water, but he actually measures out 140. So the approximate was 150. The exact was 147. So all we need to do is do absolute value, 150 minus 147 equals absolute value of 3, which is 3 milliliters. Okay, not very difficult. All right, the next one, that should have been equals there. A student measured a mass of an object to be 56. So that was the approximate, and the exact was, hang on, take that back. Yeah. Approximate was, but I also want to show you something here. Let's say you said exact, because the student measured it at 53, and the approximate was 56. We're going to do it both ways. So it's 53 minus 56, so absolute value, that's negative 3, absolute value. The absolute value of negative 3 is what? 3. Over here, 56 minus 53 is 3. 3 is 3. Guess what? The same thing. So it really doesn't matter which one of these you put first because you're taking the absolute value. So it really don't matter. Because it's just 3 grams. Okay? All right. Next song. All right. Number 3. The notes. Percent error compares the absolute error to the exact. So when calculating the mass of an object in science, measuring the distance of an object has traveled, those are the things we're talking about. This is going to be used in science. It can be solved using a percent area equation, which in the values are plugged in the formula below. So you're going to use one of these. If you're looking for the percent, you can do approximate minus exact over exact. Or if you're looking for one of these others, you're going to set it up just as we've been setting them up, which this would be part, this would be whole, if you were doing it that way. All right, so let's look at it. During a school assembly, Miss Quinn takes attendance and counts 356 students. In actuality, there are 376 students there, so she miscounted. What is her error? So we're looking for the percent error. Okay? So we're going to take 356 minus 376, the absolute value, over the absolute value of 376. So you're going to end up with, subtract these two right here, subtract those two. Going to end up with the absolute value of negative 20 over 376. What is the absolute value of negative 20? It is 20 over 376. And to find the percent, remember, all we did was divide. Top divided by bottom. And when you divide the top divided by bottom, let me show you what you're going to get. 20 divided by 376. Look at there. You're going to get 0.05, okay, which is the percent. I can't write on the screen right here, but it's 0.05. That's not the answer. You got to convert that to a percent, which is 5%. Now, when we're talking about percent of error, a lot of times it'll be 5.3%. But if you have one of these on your test, on your ACAP, they'll tell you if they want it to the first decimal place. If not, you can just round it to the whole number. Okay? But it is 5.3%. So the teacher was off by 5.3%. She can't count. All right? In a crowded sports arena, 250 seats are counted. If there's a 20% error on the count, what is the range of acceptable seats? So let's find the percent. Okay, or not the percent. Let's find what the acceptable range is. They give us the percent, which is, going to highlight them. The percent is 20. It's always over 100. Equals 250 that's the exact amount of seats. What is the range in which they can be off? Okay, well, first of all, we got to figure out what 20% of 250 is. Then they can be off, up, or down of 250. So if 250 is in the middle, they can go how many ever that way, and they can go how many ever that way. But we need to figure out what 20% of 250 is. Okay? So remember in our calculator, let's do split view again. All right. Now, let me explain. 20% is 0.20. So you take 20, which is 20%, 0.20, and multiply it by 250. That'll give you the answer. Or if you don't like that, do cross product, which I'm going to do here in yellow. 20 times 250. And then divide that by 100. And you're going to get 50. So the acceptable range means we can go 50 this way and 50 this way, which makes the answer 200, because 250 minus 50 is 200. And then if we go this way, it's 300. So the answer is 200 to 300 seats. I'll make that bigger so you can see. As you write that down, I'll get the next song ready, so get your ears ready. Next song. All right. If you can just tell me the movie it's from, you ain't got to tell me the name. All right. To the back we go, to the back, to the back, to the back, back, back. All right, read each of the situations below and answer the questions. Here we go. Several students are competing in a science club competition to build a car that will travel exactly 10 meters. The distance each student's car traveled is shown in the table below. So Emily went 9.2, Jerome went 10.6, and Marlisa went 9.8. So what is the absolute error? They were supposed to go 10 meters. So none of them went exactly correct. They all went wrong. Emily went a little short, Jerome went a little long, and Marlisa went a little short. So what is the absolute error of where they went wrong? So on Emily, it would be 9.2 minus 10 and take the absolute value. When you do that on your calculator, you're going to get negative 0.8. But remember, we're taking the absolute value, so it would just be 0.8. All right. Jerome would be 10.6 minus 10. Absolute value is 0.6. What is the absolute value of 0.6? It's positive already, so we're good. If you don't remember what absolute value is and you get lost every time I say that, remember absolute value just means whatever the answer is positive. That's all it means. And the last one is Marlisa, 9.8 minus 10, absolute value, which is 0.2. Absolute value, or it's negative 0.2. An absolute value of negative 0.2 makes it positive, which is 0.2. All right, what is the percent of error? Okay, what is the percent of error? You can use the formula because we're looking, remember, for percent. And then it's 9.2. We've already found the change, so we don't need to. Let me go back. Notice that this part is the same as that part. Notice? So if I've already found the error, I can just plug it in right here. So I've already found her as 0.8 over the original, which was 9.2. So I've already found the change. So when I do all of that math, okay, 100 times 0.8 equals 80. 80 divided by 9.2 That's supposed to be 10, not 9.2. Coach Bartman screwed that up. The answer was 0.8. That's supposed to be there we go. Now you would have gotten, when you did all that, you would have gotten 8%. The next one, you would have done the same thing. 0.6 over 10. And when you do all of that, I'll actually do this one correctly. You would have gotten 100 times 0.6 divided by, and you would have gotten 6%. And the last one, instead of 0.6, it was 0.2. So we're going to go 100 times 0.02. Oops. Divided by 10. And you're going to get 2%. All right, based on this information, this is kind of a science question here. What does the small percent error indicate? It indicates a small percent error indicates that the car is built closer to the needed specs. Specs stands for specifications. All right, it says mark each of the following statements as true or false based on the data which you've got. Jerome has the smallest percent error. Guys, that's false. Why is that false? Because Emily has 8%, Jerome has 6%, and Marlisa has 2%. Which one of those is the smallest number? 2%, which is Marlisa. Emily's race car was the most accurate. That's not true because she didn't have the smallest percent of error. The most accurate was Marlisa. Okay? Emily and Marlisa had a negative percent error because their cars traveled less than the desired distance. That is false. Because just because it doesn't meet the specs, don't make it negative. It's still off. When they make stuff at a factory, they don't care if it's off with being less perfect or more. It doesn't matter. It's not right. So there's an error there. Like if you're making a 20-inch hubcap for the car and you make it 21 inches or 19 inches, it doesn't matter. So the car's not going to run right. It's not going to roll right. So when you're talking about percent error, it really doesn't matter if it's off higher or lower. It doesn't matter. It's still off. So that's why we do absolute value of it. Next song.
Right here on the ocean floor. Such wonderful things.
I'll do one more. Next one. Pay attention.
I mean,
I got to go back. I'll go back. Here it is.
forget about your worries and your strife. I mean,
All right. Number 6, Miss Brown's class was guessing the number of gumballs in a gumball machine. All of the guesses were between 382 and 456. After counting, it was determined that there were actually 408 in the machine. What is the absolute error of the guesses below? So you take 382 minus 408. What is the absolute value of that number? So you would do in your calculator 382 minus 408, and you're going to get negative 26. So I'll show you. $382 minus 408 is negative 26. But what is the absolute value of that? What is the positive version of that? It is 26. You're going to do the same thing for 456. And you're going to end up with 48, positive 48, which is already positive, so we're good. So the answer is 48. All right, what is the percent of error of the guesses below? How much were they off? So I'm going to pause and give you just a second. Pausing now. Welcome back. So what is the percent error of the guesses below? We've already gave you the change or the error, the number. So all you had to do was this part and fill in those numbers. And I didn't tell you which one was which. So oh, what a guy, what a guy. All right. So what was the actual number? It was 408. And then what was the change? We already solved that. So all you really had to do was divide 26 divided by 408. So let's do that. 26 divided by 408. It gives us 0.063. 0.0637. Now, remember, we're dealing with percents. These are the numbers I care about. That's where it starts. So just take that away. There's your percent. Okay? And then there's your dot. All right, so it's 6.37. Now I want that rounded to the first one, 6.4. If you put 6%, okay, but 6.4 is technically correct because generally when you're talking about percent error, we'll round to the first decimal. All right, we would have done the same exact thing on the next one, except instead of having 26 there, we would have had the error from the second one, which was 48. Then we would have done the same thing. We would have divided, or if you do the cross product thing, you could have did 48 times 100, which would have been 4,800 divided by 408. Or, as I've told you guys already, if you're looking for the percent, all you got to do is divide the top number divided by the bottom number. So that's what we're going to do. So we're going to go 48. This only works when you're looking for the percent. And it is 11.76. Or hang on, let me write that the way you see it. 0.1176. Now let me go back. Remember, when we're turning that into percents, forget that. Put your decimal after the second one. So it's 11.76. 6 tells the 7 to round up, so it's 11.8%. All right. Let me give you a couple more songs. This is song number 6 coming up. Not that. That's the one we just had. All right, next one. Here we go. That's not it. Here it comes. All right. And we'll give you one more.
Hold up the sky when you were waddling yay high this guy.
All right, you only have 7 today. 7. All right. Here's the answers. Number 1. I'm not giving them to you. I'll give them to you in person. All right. I'll see you on the flip side. Adios, amigos.